Hello and welcome to week 10 in Genomics in the Cloud Book Club. I'm your host, KT Picard. In today's meeting, we'll be discussing Chapter 9, Deciphering Real Genomics Workflows, moving on from learning about WDL and how to use these at scale. We have a guest speaker today. We'll cover his lecture, then we'll go through additional resources, and as usual, we'll have time for your questions. So this week, it's my absolute pleasure to introduce our fifth guest speaker. We're going to be deepening, as I said, our knowledge of WDL with delving into these workflows of increasing complexity. Today, we're honored to have someone who's taught these subjects globally in multiple languages. Our speaker is multilingual, a French-American scientist currently working at the Wellcome Center for Human Genetics at Oxford University. Previously, he worked in Chile at the Center for Bioinformatics and Integrative Biology at the Universidad Andrés Bello, where he worked on metagenomics and human genomics. He taught programming and bioinformatics concepts, including Terra and WDL, all in Spanish. He has a PhD in genetic medicine from the Institute of Genetic Medicine in Newcastle upon Tyne in the UK. A few years ago, one of his workshop proposals, it was merged into the Broad's GITC workshop, and this PhD work became a case study for Terra. It eventually made its way into chapter 14 of our book. We'll certainly be happy to reintroduce him during our final meeting about reproducibility. Please welcome Dr. Matthew Miosek.
Thank you very much. Good afternoon, good morning, and good evening to everyone who's joining us from wherever you're joining us. And I'd like to start first and foremost by saying congratulations to all of us. As Joris pointed out in the Slack earlier this week, we've made it halfway through the book. This is the halfway point. This chapter is the halfway point. And I think it's safe to say I speak for everyone when I say we've all learned a lot, even if those of us who've come at this with some experience with genomics in the cloud, everyone's learned a tremendous amount. And so let us continue this adventure throughout the rest of the book. So I'm going to go ahead and start sharing my screen now. Let's see. Okay. So can everybody see the slides? You're on mute, Katie.
Sorry, looks great.
Perfect. Okay, so today's chapter is a natural continuation of the previous chapter, chapter 8. We introduced the workflow definition language, WDL, in the previous chapter, and here we are continuing with that concept, but taking a different approach. So this approach is interesting for two reasons. The first reason, the obvious reason, is that obviously we're going to learn some more WDL concepts through this. But it's also interesting in the sense that this is typically how you would get to grips with a new workflow that you haven't seen before. And if you're going to work with GITK, whether in the cloud or even on a local HPC using WDL and Cromwell, this is often how you'll get to grips with what the workflow does. So we have what are called two mystery workflows. So those are workflows that you're not told at the beginning of the book what they do. You're only given a hint through their subtitles. The first mystery workflow has the subtitle flexibility through conditionals. So anybody who's done a little bit of programming will have a fairly decent idea of what's hiding behind that word conditionals. And then maybe a little more mysterious modularity and code reuse for the second workflow. So we're going to see how that all shapes out. So in this particular chapter, we're not going to do we're not going to execute that many commands. What we're going to do is a lot of exploration of the workflows. So I'm going to read you the steps to get our first visualization of the first mystery workflow, and then we'll move on from there. We've already done this once in chapter 8, so I'll just do it one last time, and then we'll with the second workflow and the following one, we'll just kind of move along. Okay, so for anybody who wants to follow this live, I'm going to open the terminal now, and we're going to put that first, use an export for that first case. So export case 1. Okay, so that's book code workflows. Make sure if you're using the tabs the way I am to get rid of that final tab. Okay, so I hit tab. This is the only WDL that's in there. You just write WDL and oh, sorry, no, I'm getting ahead of myself. No, you have to get rid of the tab here at mystery 1. Sorry, we're just first mistake, live coding. And if you haven't created a directory yet, make sure you create a directory to put all our examples in today. I've already done that, so I'm just going to go ahead and erase that. And then we can just set WOM tools running. So if you remember in chapter 8, we ran WOM tools, and that allowed us to get a graphical representation using using the function graph, graphical representation of the WDL we were looking at. And in fact, I'll be calling back to that precise part of the chat of the previous chapter. You'll see why in a second. So if you go ahead and run this, it'll take less than a minute. And okay, here we go. So you can just go ahead and copy that into Graphviz and get this current, see how this current workflow looks. I'm just going to open up Graphviz. I assume everybody can see that. Okay, here we go. And then in a few seconds, we'll see our workflow. So this is our first mystery workflow, okay? And even though it's a mystery workflow, I think if everybody remembers chapter 8 from last week, this has a lot of similarities with what we've seen last week. Okay, for just so we can refresh our collective memories, I'll just show you. So this is what we just did. And oh, by the way, I put the link here if you want to quickly copy that to open up Graphviz. Here I've put the workflow from chapter 8 and chapter 9 side by side, just so that we can confirm our feeling that these two are very similar. And indeed, if you look at the left-hand side of this workflow, apart from some very slight changes in some variable names or the task call, here we have haplotype color GVCF, and here we have haplotype color, they look essentially the same, and therefore we can surmise that they do very similar things. However, we have on the right side of this graph something that looks quite different than what we've seen before. Okay, if we further compartmentalize this, we do recognize the structure of a call to a task. Okay, so we have this oval and it leads to call haplotype color. So far, so good. But then we have this rectangle box. Okay, so we've seen in the previous chapter that these rectangles signify that there's some sort of control function. Okay, in this case, there's scattering going on. You can all see my mouse, right? Yeah, okay. But here we have something slightly different because the rectangle is composed of dotted lines. So clearly that signifies something different from what we've seen before is happening. And we also have this if is cram, okay, in this control function shape, this hexagon. Okay, so those of us who've, and I think that's most of us, but I don't want to discount anyone. Most of us who've have some experience with programming will know, will have some idea of what the if statement is doing. And we could even, thankfully, sort of read it in natural English. If is cram, it essentially seems to imply that we're checking whether something is a cram. And if you remember from one of the earlier chapters, cram was essentially a more compressed version of a SAM file. So traditionally we have a SAM file, and then the binary version of that SAM file, which is compressed, is a binary SAM file, which is a BAM file. But there's also another level of compression that was created more recently using the reference as a key to do that compression, and that file has been jokingly named CRAM. Okay, so just a quick primer for anyone, even if it's just one person who's not familiar with if statements. If statements are ubiquitous in programming, and they allow for a block of code to only be executed if a given condition or expression evaluates to true. Okay, so here I've borrowed something from my Python classes that essentially demonstrate this. So we have this if statement followed by a condition, and only if this is true do we then run whatever these commands are, or these variables, or whatever code it might be. Okay. We also often have an else statement, which is everything that runs if that condition is false, and then anything below that that is not part of this construct runs either way. Anything before or after runs either way. Now, it is possible in most, if not all, these programming languages to just run an if statement. And indeed, in what we have in WDL is a construct that only has that if statement. So essentially, what it's saying is, if this particular variable, which we for now we're not quite sure what it is, but we know that it'll be a variable that surely evaluates to true or false. If this particular thing is true, then we run that. If it's not true, we just don't run it. Okay, so this is something that only runs if isCram evaluates true. And what we see that it runs is a call to a task, the cram to BAM task. Okay, and here I've highlighted the two brackets that signify what runs when this is true. So everything inside those two brackets only run when isCram is true. So that already gives us a lot of hints as to where we're headed with this, right? If we remember that I'll go back to the workflow here. If we remember that previously when we ran this pipeline, we were inputting a BAM file through JSON, which we could also input through the command line as well. Here we have essentially added the option to add a CRAM file as input. The thing is that haplotype color doesn't reliably accept CRAMs as input, so we do have to transform it into a BAM, something that haplotype color will accept. Thus, we have this call to a task, CRAM to BAM task, that when in the event that it gets called, then sends its output to haplotype color, something that will become relevant in a short while. Okay, so I'm getting a bit ahead of myself. So what we're going to do now is we're going to look for that particular bit of code, just to show you how easy it is to find it. So if I go to, actually, I'm going to use less here, which is, if people are not familiar, it's a way to crawl through a file using the up and down arrow keys. So I'm going to write case 1 WDL, and I'm going to go through this very first WDL. Okay, so first we have a look at the calls, and here we have the CRAM to BAM task, okay, which I was just showing in the slide. And so we have noticed, therefore, this is CRAM, and therefore the next question that we might have is, well, how do we define if isCram is true or false? And if it exists here, it must have been defined somewhere. So if it has been defined somewhere, it stands to reason that it would be somewhere before. Okay, and here it is. We have this Boolean isCram. Okay, so a Boolean is exactly what we need, because a Boolean is a value that either true or false. however you get this this value, it's going to be true or false if it's captured in a Boolean. And then we have this expression, which we can see as an evaluation of whether this particular part is equal to that particular part. Now, that might not be immediately obvious, but I'll just show on the slides what that looks like. So yeah, so you have to imagine that this sub-base name, all of this is one component that we are comparing to another component, this cram. And what we're trying to do here is determine whether a file that we have that we're using as input is a BAM or a cram file. You'll have noticed that here, in order to determine that equality, we have a double equals. We use that form in all programming languages to avoid ambiguity, because when we have just one equal, that means you're assigning a value to a variable, okay? So this result is being assigned to this through this equals. So in order to differentiate that from comparing two things and determining if those things are actually equal, we use equals equals. So let's imagine we have an input BAM file. Just for the sake of it, I've actually given it a cram extension. In the book, it has a BAM extension. So we see the other scenario where this evaluates the true. So we've already seen what base name does. Very quickly, base name essentially gets rid of the file path and just keeps the file name. So we end up with sample cram. And then this sample cram gets transformed. So here we have a bit of regular expression. I won't go into exact detail about the regular expression. I've put a link at the very end for anybody who's interested in deciphering this. And I think KT Picard as well put up a link on the Slack about regular expression. But essentially, it separates the parts of sample.cram using the dot as the separator. So you end up with sample and cram. And in the next step, you replace that first element, which is sample, with an empty string. So that's just 2 quotation marks. Okay, that leaves you with cram. So essentially, what this all boils down to is the following: Boolean is cram is equal to whatever the value, truth value of cram compared to cram, which is true. Okay, if we had BAM here, then it would be false. So now we know how we get that is cram value, and we see that essentially what happens is that we've written a series of functions to determine if a file input is a cram file or a BAM file, and based on that, we're going to use the cram to BAM task. Now, the next question we might have is, okay, so we've done this, but how does this affect the rest of the workflow? We've seen that if we go back to our workflow graph, we've seen that the result of, or some result of cram to BAM task then gets passed on to haplotype color. So surely that has some sort of effect because haplotype color can't know in advance whether it's going to receive a BAM file defined in a JSON file, or if it's going to get a BAM file that was previously a cram and was converted. So let's go back to our console and see if we can find some sort of clue. So if we go down to haplotype color where the next actions are happening, immediately two lines stand out, right? Because you have this new function called select first. And select first is, in some sense, another version of an if statement, right? In the sense that you're given a choice between two things and it's one or the other. So what's happening here? What's happening here is that it's looking for the output of cram to BAM task. So if it's for the BAM file, it would be output BAM for the index that goes with it, output by. And if it doesn't find it, i.e. if it hasn't been generated because is cram was false, then it just goes it retrieves directly input BAM and input BAM index, which will be the file that was defined in your JSON file. So the interesting thing with here is that it's essentially looking for something that might not exist, and if it doesn't exist, it goes on to the next thing, which is a bit different than what you might see in programming languages. But here we are. This is a workflow language. So that's essentially the thing to remember about select first. More often than not, you're basically asking it to choose between a file that may or may not exist and default, shall we say. Another example of that would be if you have a variable make GVCF. Notice that question mark before Boolean. This signifies that this is an optional variable. So you can define it in a JSON file or in the command line input, but you don't have to. And if you don't, what happens is simply, as before, is that it goes to the next value. In this case, this has been hard-coded directly inside the select first. So it looks whether the user has defined whether making a GVCF should be true or false, so whether a GVCF should be made or a VCF should be outputted instead. And if the user doesn't say anything, then that evaluates to true. This can be true as well, which is a bit redundant, but that can happen, okay? But if this is false, this is what's going to be selected, okay? And if this is doesn't exist, if that variable doesn't exist in the JSON file, it just defaults to true. So select first is a good way to define default values. Okay, so that essentially gets us through the first Mr. Weird workflow. Obviously, there are some other aspects that you can take the time to explore that are in the book, but in order to keep with the time, we're going to move on to Mystery Workflow 2. Which had a more perhaps less obvious title, which was modularity and code reuse. So what's going on there? And again, if you want to create a graphical representation of that mystery workflow 2, you go through the same steps that I showed for mystery workflow 1, and you end up with something like this, okay? Now, in the book, they present it as a workflow that does quite a lot of things. And indeed, if you look at the names of the actual calls to tasks, they do imply that a lot of things are being done. Unmapped BAM to align BAM suggests the entire pre-processing step. BAM to GVCF kind of harkens back to haplotype caller. So there's a lot happening here, and yet we have a graph that seemingly looks much simpler than the graph we just looked at, which sounds very counterintuitive. So what's happening here? Well, the first clue that something is amiss is the fact that we have ovals that have double outlines. So clearly something different from what we've seen before is happening here, okay? And as the book points out, we don't see anything in boxes, in rectangles, which suggests that there's no, that there isn't any function control, but that is that seems to be that would hardly seem logical. So let's have a look at this workflow then, and see what we can see what we notice straight away. Okay, so in order for that to work, I need to quickly point to case 2, which unfortunately I have forgotten to do. Those things happen. But that gives an opportunity for anybody trying to follow at the same time to quickly do it as well. So, okay. Now we have mystery workflow 2, okay. And we're going to go ahead and use less again. So here we have our WDL. And again, the name of the WDL itself suggests that there's something quite intense happening. So it's very surprising that we see such a small graph. Now, if we focus on the calls, we immediately notice something different from what we've seen before, right? We have, for example, here to BAM, dot unmap BAM to align BAM. We have this dot here that we haven't seen anything like it before. And this seems to be true of all the calls that we have in this particular workflow. So what's happening here? It's not clear at this point. Now, if we go down to the tasks, okay, all the way down to the tasks, whoops, there are no tasks. There are absolutely no tasks. So what on earth is happening here? Some of you might have noticed earlier in the file while I was scrolling that we have all these things called import. Now here, I think there's a slight error, and actually those imports here should be uncommented and these should be commented, but we're going to act like that's the case. I think this is just because we're pioneers, so you know there's occasionally some errors. So let's just pretend those are commented out. These are our import statements. This is the first time we've seen these import statements, and we notice immediately that the final part of each of these import statement harkens back to our call. So for example, to BAM, if we go through here, this first call says to BAM and has that dot unmap BAM to align BAM. So we can't find this particular name, but we do have to BAM, and it's the same with the other ones: aggregated QC, to CRAM, QC, and to GVCF. They're all here. They're all here as aliases, with maybe the exception of this here, germline structs WDL, WDL, sorry. And we have another clue here, which is tasks. So to summarize this, we have our calls to tasks, but they seem to be connected to tasks that are not in the WDL that we're looking at. But we've noticed that there are other WDLs, and that these other WDLs are connected to these calls. Now, the one thing I forgot to mention that I'll mention now is that in both cases here, we have this as, okay? And this, if you've done any shell scripting, you will have seen that before. And even if you've imported stuff in Python, you'll have seen that as well. Basically, we are telling WDL this very kind of awkward expression, just go ahead and call it this from going forward, and that will just simplify things. So it would be like, for example, calling me Matt instead of Mathieu, so that you can, you know, it's much simpler to say. So any references to this particular call, for example, as input to other calls, is just going to be BAM to GVCF. Okay. So essentially, we're saying here's our here's a WDL that we're going to use. This is the name of the WDL. So here we're referring to the entire workflow inside this WDL. Okay. So let's go and find this. And by the way, this is what's called a sub workflow. So spoiler alert. We have workflows within workflows. Okay, so let's go to our console now, and let's first have a look at what we have in this folder. So I'm just going to go and put ls. And we notice that there's two folders, structs and tasks, and one of that folders, tasks, is what we're looking for. Let's go ahead and take a look in tasks. Okay. And lo and behold, there's a whole bunch of WDLs here, and a lot of them, if not all of them, actually not all of them, but some of them are associated to the WDL that we've just seen. So some of these are mentioned in the import statements. Okay, so for example, the variant calling WDL is one of those. So let's take a look at that one. So if we go less variant calling WDL. Okay, so we have another workflow, and immediately we can see it says workflow variant calling. So this is what if we go back to the slide, this is what this variant calling is referring to. It's saying in this WDL file, there is a workflow variant calling. So go ahead and run that, and here's the input and so on and so forth. Okay, so we're making some good progress here, elucidating what exactly is going on. And this is an opportunity for me to mention the fact that if one particular WDL file can have multiple workflows. Okay, so it makes sense to explicitly refer to the workflow. I don't know how common it is to implement multiple workflows within the same WDL, but it's possible. Okay. So here we are. We have a number of calls inside this particular WDL, which are all going to be run once we call to GVCA variant calling. However, if we go and have a look at tasks, well, there is a task called merge BAM outs, but that's it. And we've all seen that we have more than one task here. So clearly, again, we have this issue of tasks have gone amiss. And here we see again, we have ignoring the comments, the commenting out here with the hash symbol. Here again, we have import statements, and these import statements have their aliases, and so we're now realizing that we have basically other sub workflows within the sub workflows. So you have a whole network of workflows. But already variant calling makes as a WDL makes a lot more sense. If we were to map it out, and here is what it would look like. You already see a lot of structures that are familiar. You have the calls, and then these are controlled by scattering and by if statements. You can see here we have something that's equivalent to an if statement, because we have it's being asked if whether it has the GATK3 to use the GATK3 haplotype color or not to use it or to use it, right? That exclamation point means not to use it. So we have one or the other. I can show you real quick where that is in the file. So since this is WDL, this is defined using two if statements. Let's see where that is. So here, if use GATK3 haplotype color. So if this is true, if it's false, which is this condition, then you run this version of haplotype color. So this allows us to either run GATK 3.5 or GATK 4. Okay. So that was a little parentheses. Going back to therefore this workflow, it makes a lot more sense, but we still see that there's quite a few tasks missing. So let's go even further and look, for example, to the QC WDL. Let's have a look at the QC WDL. So we have a look, it's in the same folder. Okay. And here we have something completely new. It's just one discovery after the other. We have a WDL. We have a WDL that doesn't have a workflow per se, doesn't have calls, it just has tasks. Okay, so it just has a series of tasks. And so it's not a mystery at this point where these tasks are being called from. They're being called from files at higher levels. So we can ask. So we already know that variant calling, that WDL calls this QC file. We can also ask whether maybe some other WDL calls this QC. For example, the one that we started with. We go back to that one. See, this also calls tasks from the QC WDL. So here we have an example, an illustration of why we're doing this in the first place. Because one question you might have when you're starting with WDL for the first time is, why break it into pieces? Why have this? Okay, I get the idea of modularity and code reuse from this, but why are we doing it anyway? We're just running one script. And one answer is, well, if you want to run, for example, some quality control scripts at different levels, at different parts of your workflow, this is one way that you can do it. Okay, so you don't have to write the quality control twice. The other reason is that, sorry. The other reason to have this like this is that, well, let's think back to where we're getting all these examples from. Okay, we are getting all these examples from, let me see if I can get the page, the GITC workflows GitHub page. Okay, so if you remember at the very beginning of the chapter, there's a link easily missed to this GITC workflows page, and here you have all of GITC's workflows. Now, having gone through the previous chapters where we did germline mutation, somatic mutation, like how you call these, it will surprise no one that a lot of tools get reused, right? So a lot of the, to mention the obvious one, a lot of the pre-processing is the same, transforming an unmapped file to a mapped BAM file is essentially in many parts the same for whether you're going to look for germline mutations or somatic mutations. Okay, so what happens here is that everything that doesn't need to be implemented twice only gets implemented once, and so if you imagine two different, what we're going to call master workflows, these two can both refer to the same sub workflow, and therefore you avoid reinventing the wheel every time you want to create a whole new workflow. So the workflow for somatic variants and for germline variants is going to use some of the same processes, and it's going to do that using the same sub workflows. And these sub workflows can either have just the tasks implemented, or they can have calls of themselves, okay, as we saw. And this is essentially the final point on that. One mystery that we still haven't quite solved, although I suspect many will have figured it out, is what is the deal with this double outline, and why don't we have double outlines for example, call collect WGS metrics or call collect raw WGS metrics? And the answer is essentially that for those with a double outline, we have an entire new workflow, we have a sub workflow, whereas for these metrics collections, we have tasks. Okay, so essentially we have in one case, we have our master workflow depending on a sub workflow, and in another case, we just have a WDL file that has tasks that can be called upon. Okay, so essentially, in reality, if we were to map this graph out, and I'd be actually, I don't know if this is possible, but I'd be interested to see if that's something that can be done. If we could map this graph out to take into account all the different WDLs and what they contain, this would be an enormous graph with a lot of control functions and arrows going in every which way. Okay, so with this, we've covered our mystery workflow, our second mystery workflow, and essentially we're all set to in the future be able to read these workflows, even if we haven't created them. So this is a good skill to have. I have myself experienced the joys of going through a workflow and trying to figure out how it works. So this approach of looking at the calls first and then working back from that, is a good skill to have. So with that, I think we're at with 15 more minutes to go. I'll just mention some quick additional resources. Obviously, Lynn Langit did a very good job of covering most of the resources that there is for WDL. So I'm only going to add one or two things, which is Geraldine pointed out recently that we now have WDL version 1.1 specifications, which are worth looking at. And I will add to that what was written in the Twitter post that she sent, which was that there are no breaking changes in this version, which means that all the scripts that we've seen that say version 1.0, you could change those to version 1.1, and they would still work because they are backwards compatible. And then as a final addendum to what the links that Lynn Langit shared with us in the previous week, I will point out that there's a Slack channel. We're all using Slack, so I'm sure that most of us are Slack enthusiasts. There's a Slack channel for people who want to interact with other people who use WDL and ask questions and maybe suggest some updates or some problems that need resolving. So if you're interested in diving deeper into WDL, the next chapter is more going to be about Cromwell than WDL, but you can continue that adventure in parallel, joining that Slack channel right there. And then the last thing I'll say is there was one bit of regular expression that we had, which might have not been clear to many. To me, it was also a little bit difficult to decipher, which was, let's see, here, okay? This regular expression is the same as generic regular expression. There's no specific rule independent, like that's particular to WDL. So if you want to learn more about regular expression, Wikipedia is a good place to start. If you really want to delve deep into that aspect of the WDL, and as I mentioned before, Katie has also posted a link about regular expression that I had forgotten about, but I just saw it like an hour before this presentation, so you can go ahead and check that too. I'm sure Katie will repost that again. And well, that's it. That's it for me for today. I hope that was. I hope that helps with the with getting through this chapter if you haven't already, and I hope that was useful.
Mathieu, thank you so much. That was a wonderful introduction to the chapter, and you did a great job of walking us through those mystery workflows, and they're not quite as mysterious as they were 45 minutes ago. So thank you for that. Yeah. I'll kick it off with a question, if you don't mind. And we have a few minutes here. One of my questions was around the way that you've learned how to debug these workflows. And the way that we went through them in the book was kind of top down, where you looked at code and went through the import statements that cascaded down into the bowels, if you will, of things like qc.wdl and that sort of thing. I'm wondering if you had to do it the other way, where, for example, if you had to make a basic change to that QC WDL file, how you could figure out where those modules are used. If there's I mean, this is kind of more of a programming question, but when you're debugging and you have to make a basic change, how do you know which other WDL files are affected by lower level changes to your code? Is there a good way to kind of see where how bottom level changes will populate up into the rest of your workflow?
Well, that's a good question. I wish I had the answer to. Well, one thing that I suggested would be helpful was if there was a way to create a graph that actually shows you the extent of the entire thing. I don't know if that's possible. Maybe Geraldine or Lynn could at a future time answer that question. I'm not sure. Thankfully, in what I've done, that hasn't shown up yet. The changes that you typically do to workflows like the GATK workflows are usually ones that occur really in the master workflow or at some level that's very close to the master workflow, thankfully. But that's definitely something. It would be interesting to find out how that can be done.
Yeah, to jump in quickly. Sorry, I joined a little late.
Here you are.
Yes.
Welcome.
Thank you. Really nice job, Mathieu. I only caught the tail end, but it was cool seeing this. I know it's an perhaps unconventional view of the workflow, so I'm interested to see how it lands with all of you. On the question of being able to visualize the whole thing, I don't have a completely straight answer, but I remember a Slack discussion with one of the developers, Chris Lanworn, who's one of the leads on Whittle and Cromwell on the Broad side. And so his team develops the graphing utility. I think there was a discussion around adding some functionality to make it possible to display everything, basically unpack the imports. If that hasn't happened yet, it can always help to have a little bit of a public demand. If people go in the GitHub and say, hey, it would be really nice to have this, that's one of the ways that things get added. So don't hesitate to go in there. But I'll drop Chris a word as well, because I do think it would be helpful. I have found that when developing Whittles, honestly, sometimes just text search. I have everything open and I do a text search, and it's not, because depending on your editor, if you can do a multi-file search, that can be really helpful. Typically, the kind of changes that end up bubbling up, in my experience and the kind of workflows I've worked with, are like if I have a task that I use in multiple places with the alias, call something as other name, I'll try to hunt to see if there's any like multiple calls that are aliased, because that's one of the things that can bite you. The other thing is with the introduction, I think we touch on it in this chapter, of the structs, where you have the structure that packs multiple inputs together under a custom structure, object structure. That is one place where you could end up in funny places if you make modifications to the structs, and they're used in various places. But I'd love to hear what others have experienced.
Well, my question's kind of along the same lines. This is Adelaide. How you doing? I was curious if there's a strategy to making the modules like in a certain order, or to like have, what's a good bite size for a module when you know that you've got a complete unit and then stringing them together.
That's a really good question. I mean, our data engineering group has done a lot of experimenting to be able to modularize, because they used to have just one big pipeline to run in production, and then they added like a version just for exomes, and then they added a version, like the somatic pipeline reuses a lot of the same code, and they've done a lot of post hoc modularization, where they didn't try to modularize everything up front, but they had one big pipeline, and then they refactored it when they realized they could reuse some code for another pipeline. And the principle there is to avoid optimizing too much up front, and instead just kind of write a first version that works well for you, and then when you realize you can optimize things, just refactor, and in the process of refactoring, meaning rewriting some of the code more optimally, you often find opportunities to clean other stuff up. And it's sort of a iterative improvement. So I know it's not really a question to what is the right place to modularize, but I would say the right place is the right place, the right level that works to achieve your objectives in the moment. I'd love to hear if people have other opinions on that topic.
Yeah, well, I think that's what I would have guessed, that it was something that was kind of done progressively, step by step. Like people said, okay, actually we need this part that's in this particular WDL, so we're going to externalize it so that we could use it for these two master workflows instead of just the one. Because otherwise it's a little bit, when you're just using one workflow and you have it kind of broken into pieces and you don't see the other workflows they're using, it does kind of feel a bit counterintuitive. But I would imagine, yeah, that's a progressive process.
I guess I tend to think very linearly. So like I tend to, well, I do a lot of RNA-seq stuff, for example. So the pre-processing steps, sometimes you want to trim and sometimes you don't need to trim. So I guess I tend to go into the simplest chunk of something that I might take out or put back in, kind of like what you just said. Like there's a piece you want to reuse consistently, but there's also the opposite situation where there's a piece that you sometimes want to ignore just for the sake of time.
Yeah, I feel like it's a trade-off, but it really depends on what the goals of the project. Like, are you making stuff for external people, or are you making them just for you? I feel like that makes a big difference. Like I've seen with the GITC itself, the code has evolved to modularize more things and parameterize things that initially you just bake in, and then people like, wait, but I want to be able to play with those parameters for my weird interesting use case that doesn't, and then you go in and parameterize stuff. I feel like workflows it's okay to treat it that way. Like if you have a grand master plan and a grand design, that's cool. But I think it's hard to do that up front.
Yeah, and if I could build on that, speaking of the grand master plan, and all plans, of course, get changed. One of the things that I noticed in the GATK workflows page on GitHub is that, I think it's on GitHub, in any event, there's kind of a transition that's going on, and we've touched on this on Slack, where certain workflows are being archived as they move off to Warp. And the page that Matthew brought up is indeed a good example where we're not quite there yet. Some of those have been archived and moved to Warp, others are kind of in process. And I just wanted to point out that we have, coming up in subsequent chapters, more about Cromwell and more about Terra. So we'll have a chance to explore how those workflows have changed. And I'm curious if, especially around Terra and Warp, where we are with the kind of movement of these workflows into, will this become obvious to us, Geraldine, or what are your thoughts there?
I mean, to some extent, as I mentioned on Slack, it's in part a consequence of organizational changes at the Broad, which I wish nobody on here would have to worry about. Unfortunately, right now you probably do a little bit, just because in terms of finding where the resources are and so on. It's a sign of more like the data engineering group taking more ownership of the final optimized versions of the pipelines. And it's kind of like things in GITK workflows are things that are directly owned by the GITK group, who are, tasked with putting together pipelines that answer the scientific problem accurately and as correctly as possible. But then the data engineering group will often take that and optimize for speed and cost and stuff like that, just make things run cheaper, because they're going to be the ones who are running those workflows in production on ridiculous numbers of samples. And so you have to make it as cheap as possible to optimize use of research dollars. And so it's kind of that transition. The things that end up in Warp are the things that are super optimized and productionized and are made to be super robust for a specific use case. And that's like, if you just want a push button solution because your use case matches the requirements, like, you can take it and it should work out of the box super efficiently. But there will always be kind of more in GITK workflows. They might just be a little more rough around the edges and because that represents more like the cutting edge part. And actually in the GITC repository itself, there's even more like raw pipelines that we have not yet really exposed their public, but we don't attract attention to them because those are really experimental. And so there's kind of a movement, a maturity process, a maturation process for the workflows through those repositories. And maybe it's not a bad thing that that's a thing that happens, because you can basically gauge based on where you're finding it, how likely it is to be just push button versus something you have to tinker with a little bit. So that's kind of the, to address the question of the pipelines as such and where they are. The other, in terms of Terra, that's even a kind of a different world, in the sense that there, the goal is really to provide a place where you can find or use things that you found elsewhere in a way that abstracts away a lot of the complication of setting up your own, like managing your own VMs and stuff like that. The goal there is that there's a lot that's managed for you, and there's a lot of content that's preloaded and pre-configured to make it even more push button. But at the same time, giving you all the flexibility that if you want to run your own stuff and develop your own stuff, it's not like you're locked in and you can pick from 3 pipelines. Like, you can bring your own, you can import from DocStore, which is great repository that I think we've mentioned before. So I'm excited to move towards that part of the book too, because it's.
We are too. This is, here we go. So we've got a few more chapters to really get a solid understanding. And as you mentioned on Slack, you said, it's a lot like flying the plane while you're building it. And I think that was a very apt analogy about where we are with workflow. Whittle still is kind of a work in progress. You mentioned 1.1, and so it's still a work in progress, if you will. So it's exciting to be on the cutting edge of this, and it's been a lot of fun unpacking it and watching it evolve. But I think it's a normal process when, as technologies mature, as you say. There is a certain process where you just have to move things around and build a bigger house, right? To hold all these things.
Yeah, and it's just, in genomics, it's going to continue evolving as, the work of the telomere to telomere group is super exciting, of making references that are completely finished. Because right now we say we have finished human genomes, but there's still big chunks that are like gray areas. The T2T group is mapping out everything for specific genomes. There's also like the pan-genome work. There's the graph genome stuff, which is super exciting, but will require major changes to the tools, how the tools and the pipelines work. So the thing in genomics is you can never really rest on on your achievements, because it just keeps moving as the technology keeps improving. Adelaide mentioned RNA-seq, like single cell RNA-seq is a huge world of exploration right now. Very promising as a technique. There's a lot of data coming out, a lot of really interesting findings that are coming out of there, but also like there's a huge number of different tools with different requirements. There's a lot there that needs to be standardized to make it accessible to people who haven't been playing with it for 5 years already. I mean, 5 years is as far back as it goes, I think. Anyway, so yeah, there's a lot of really exciting stuff, and it stays interesting, I guess.
Right, keeps us going. That's very true. So we have time for one last question from our members before we call it a day for this chapter. Anyone else with a question for the team?
No more mysteries.
No mysteries. What do we say? Is it achievement unlocked? I can't remember, but I think that's what we've just done.
There's definitely an achievement unlocked effect of, like, once you're at this point, you've done all the work you're going to do on the single VM. Well, maybe I might be lying slightly, but starting next chapter, it's like you're going to scale things up and command fleets of VMs. That's going to be awesome. Looking forward to it.
May I just ask a very silly question? It's about syntax, but when we are speaking about nested workflow, it means that we have like a master workflow and we have a sub workflow inside. So it's like a kind of adjective to refer to all the workflow.
Yeah, so the nested workflow is just yeah, as you say, there's the main workflow, and then that workflow imports other workflows. It basically outsources some work to other workflows, and it can be just like it runs that workflow one time, but you could also have a scatter where you're running the same workflow 50 times on 50 different samples or stuff like that. So there's different manifestations, but that does refer simply to importing one workflow inside a bigger workflow. And you can have multiple levels of nesting. I don't think there's a hard limit on how many you can do. At some level, the complexity probably becomes too much to handle, but yeah.
Thanks.
Sure.
I mean, thank you. Yeah, I noticed that in the workflows that we were, the mystery ones, you know, they tend to go down 4 or 5 levels, and then you kind of bottom out in the utilities and QC and that sort of thing. And in general, that's about as much as my brain can handle, is kind of 5 levels of recursion, and then it's just pop, right? And then it goes out of pop-up logic. So.
Well, you say recursion. I don't think anybody has, I don't know if there's any control against like calling the main workflow back in the nested workflow. I don't know if there's any hard guardrails against that. You could do some really weird stuff if you have a mind to experimenting. Probably.
We'll leave that as an exercise to the reader.
Yes. Yes.
Right.
I'm not encouraging weird behavior.
Right. And let us know on Slack if you found something really interesting with WDL that unlocks the secrets of the universe. We'll call it a day today, and want to thank all of our members for their questions. Okay, everyone, thank you again so much. Looking forward to moving on next week to Cromwell and the Pipeline API. Please join us again next week for another edition of the Genomics in the Cloud Book Club. Thanks, everybody.